Okay, good afternoon. We're going to continue with that questions. Okay, questions in the book. Question in the book. Sorry, the paper. Question for the paper. And we did question until question number 6. Question 6. Okay. Question 7. Question 7. We're going to do question 7 now. Question 7. Okay, question 7. What is shows the use of spring in vehicle. What is the meaning of elasticity? What is the meaning of elasticity? Okay, the elasticity. What is the meaning of elasticity? They ask the question. Okay. Elasticity means property of material that enables it to return to its original state or shape or dimension when the external force act on it is removed. Okay, I'll teach again. Elasticity means property of material that enables it to return to its original state or shape or dimension when the external force act on it is removed. Okay, that's called property of elasticity. What is the function of the coil spring in the vehicle? What is the function of the coil spring in the vehicle? The function, the spring, something like a shock absorber. They got shock absorber in the car, the tire or the spring, the tire, and to absorb shock, Okay. Next question. Question C1. Question C1. Sketch the Hooke's law on the graph below. Mark elastic limit E on the graph. Elastic limit. Okay. Hooke's law. This is Hooke's law. Okay, this one is they put a box here. So the force Newton, the force versus unit Newton, and the box here also x for extension. The unit is meter. Must be meter. They put centimeter, but meter. SI unit meter. Force unit Newton, x extension, and unit cm. So the graph like this. Okay, this question, very interesting question, because there's something extraordinary thing asking. Normally they ask draw Hooke's law. Normally the draw has to draw Hooke's law. Forces versus extension. Hooke's law must be straight line, original, passing or directly proportional, or the graph start original. But since the question asking you second question, C1 is a force, the graph lah. C2 they asking mark on the elastic limit E. So since they asking elastic limit, then you must draw. Okay, you must understand this one. Hooke's law, this is a graph. Hooke's law, this is a graph. So since they asking elastic limit extra portion, then you have to draw like this. Okay. This one, the graph, you must put curve. Okay. And this one is elastic limit. This one, elastic limit. They put the E, they put E point. They ask for label E. So elastic limit is elastic limit. Okay, and question D. Since question is 1 and 2, question C 1 and 2. So elastic limit. So I'll tell you again. If they ask Hooke's law graph only, you must draw up to E only. You don't draw the graph. Don't draw the curve. Since they ask what is elastic limit, they ask label elastic limit, you have to put curve and put elastic limit. Okay, question B. Based on diagram 7.1, suggest 2 modifications that can be done to the spring so that it can be loaded with a bigger mesh. So that it can load bigger mesh. The spring can load bigger mesh. The spring can endure bigger weight, or the spring can sustain a bigger weight and bigger load. Okay, diameter of the spring. The diameter of the spring must be bigger. Bigger diameter of the spring. Bigger diameter of the spring. Okay, what is the answer? The reason because stiffness increases. Stiffness increases. Okay, when you stiffness, very stiff. Okay, or stiffness, or force constant, or spring constant. 3 names are given. Okay, force constant, spring constant, stiffness spring. Okay, 3 names are given. Okay, and the formula for this, F equals to Kx. This K means force constant, spring constant, stiffness spring. So in this case, stiffness spring increases. So when force increases, extension increases. F equals to Kx, the Hooke's law formula. Okay, the force increases means extension increases. Right? When the force increases, extension also increases. Okay, and okay. Put a 9 meter light. Okay. Okay. Diameter spring. Okay, there are 5 factors influence the stiffness spring. 5 factors that influence stiffness spring. 5 factors. Okay. The first point, diameter of the spring. Diameter of the spring means the diameter of thickness spring. Diameter of coil. Diameter of thickness of spring. Diameter of the spring means thickness spring. So you must thick spring. It's not diameter thick spring. So this is a bigger coil, bigger thickness of spring, or diameter of spring, bigger diameter. This one is same coil, but thin spring. So thick spring. This one thin spring. So thick spring and thin spring. The thick spring or diameter of spring increases means thick spring. Thick spring. Thick spring means can endure more weight, can sustain more weight or more load. Okay, because stiffness, higher stiffness, K value will be higher. Stiffness of a spring increases. Okay, another spring, this is called diameter of spring. Another one is called diameter coil of spring. Diameter coil of spring. Diameter coil of spring means there is. Okay, this one is a bigger diameter coil. It's a smaller coil. It's a width. It's bigger coil. It's bigger coil. It's a smaller coil. Smaller coil is a stiffness higher K value. Higher K value, this one K value will be low. K value here might be K value be higher, this one K value be lower. K means stiffness spring. So thick spring having higher K value. Thin spring having lower K value. Coil of spring, diameter, the two things are diameter of the spring or diameter of the thickness spring, that means the thickness spring. Another one is diameter coil of spring, coil, bigger coil or smaller coil. So smaller coil is having K value, higher K value. Okay, this is a smaller K value. Okay, this is a coil, smaller coil. Okay, this one diameter of spring maybe increases. The reason stiffness increases. Length of spring, the spring should be shorter. Length of spring decreases. Okay, and the reason for this, stiffness increases or harder spring. Okay, harder spring. So another factor, length. Okay, like this. Okay, the shorter spring, so longer spring. The shorter spring K value is higher. This one K value is lower. Shorter spring with K value higher. So K value is higher means stiffness spring increases. Stiffness of spring increases. In other words, force constant, spring constant increases. Higher K value increases means K value increase. I repeat again. K value increases means stiffness of spring increases. Force constant, spring constant increases. So, or spring, harder spring. It's not softer spring. Lower K value is a softer spring. This one harder spring. It's a hard spring will be hard. Hard spring or strong spring, okay, can endure more weight. More weight or sustain more weight, more load. Okay, and harder spring. So the reason is harder spring or stiffness increases. Okay, and okay, that's all for question number 7. Now we are going to do question number 8. Question number 8 shows 2 types of sheep to use locate under. Okay, maybe I'll teach you another 2. Maybe before teaching question 8, I will teach you 5 factors. The first factor, thickness spring or diameter of spring. Second factor, coil of spring, diameter of the coil of spring. Third factor, length of spring. The shorter spring or length is lower, length decreases is better, higher spring. And the fourth factor is a type of the spring. Type of the material. Type of the material is the fourth factor. Type of material. The material normally iron or steel. Steel, aluminum. Steel having K value, higher K value. Aluminum having K, lower K value. So steel might be harder spring because having higher K value or stiffness increases or force constant, spring constant increases. Steel. Okay, type of material is the fourth factor. This is the first factor. The second factor is the third factor, length of spring, and the fourth factor, type of material, and the fifth factor, method of arrangement. Method of arrangement. So the spring can be series, parallel. 2 spring 1, spring 2. The spring 2 spring arranged series. The 2 spring arranged in parallel. So it is parallel. This was series and parallel. So the parallel spring is harder spring. Parallel springs harder spring or K value is higher. K value is higher, K value is low. Okay, the parallel spring is harder spring. Parallel spring is harder spring. Okay, or higher K value la, because of the what do you call it metal arrangement of parallel springs, harder spring or K value higher or stiffness of spring increases. Force of the spring constant increases. Parallel spring, harder spring. Okay, another thing I want to teach you is five factors. Okay, five factors. Five factors influence the stiffness of spring. Five factors influence stiffness of spring. Five factors. Okay, and another important thing I want to teach you about a graph. This graph, the K value, you can gradient of the graph. The gradient of the graph shows K value. K means force constant, spring constant, stiffness spring. Another type of graph, this also sometimes ask exam, X versus force. This one forces versus X. Okay, X versus forces also is a directly proportional graph. Directly proportional graph. X versus force. If they ask to draw elastic limit, the graph like this, curve downwards. This one curve upwards. This one curve downwards. This is E point. E point elastic limit. But this one, the gradient of the graph shows. 1 over K. This directly forces versus extension X. The gradient shows K. X versus force, the gradient shows 1 over K. The gradient shows 1 over K. Okay, the gradient shows 1 over K. This one gradient shows K value. Okay, and the graph, you must understand the graph. Okay, X versus F versus X. Okay, please understand this. Normally they ask this graph F versus X, but I've seen this question where they ask to draw something in the question. They ask question X versus F. Okay, curve down. If the last limit is it, this one is the gradient shows 1 over K. Okay, this one is a question number okay, we are going to do question number question number 8. Question 8. Table 8 shows two type of sheep used to locate underwater object and their characteristics. Okay. What is the meaning of transverse wave? What is the meaning of transverse wave? Transverse wave is what is called transverse wave is vibration of particles. Vibration of the particles is perpendicular to the direction of propagation of wave. The direction of propagation of wave, that is called transverse wave. Direction perpendicular, 90 degrees. Okay, perpendicular. Okay, the vibration of particles is perpendicular to the direction of propagation wave. That's called transverse wave. Okay, question B. Based on the diagram, table 8, state suitable characters of sheep to locate underwater object. So much using ultrasound, underwater object, fish, underwater object, or locate the fish. Okay, this is this underwater. This is a boat. Okay, it's a boat. Okay, they put it. The sand is signal underwater and the signal reflect back. So maybe underwater object, this one underwater object, you want to locate a fish, underwater object or depth of sea, they use ultrasound and they check ultrasound and reflect back. Reflect back. Okay. And what the characteristic or type of wave? Ultrasound. The type of wave is ultrasound because it's having high frequency. Ultrasound. What is meant by ultrasound? I have seen this one question. I've seen many, I think many times I've seen this question. Two times I've seen the question. What is meant by ultrasound? Ultrasound is a sound wave with a high frequency or high frequency sound wave. High frequency sound wave is called ultrasound. Okay. What is the reason for this? The type of this wave is ultrasound. The reason because having high frequency, the wave having high frequency. Because high frequency can penetrate into sea. High frequencies. Okay, deep sea. Okay, next question. Frequency must be high. Next question. Frequency must be high because the reason because having high energy. High frequency, high energy. Because higher energy can penetrate the sea. Okay, higher energy is having higher energy. And cathode ray use of cathode ray oscilloscope. Cathode ray oscilloscope number 3. Use CRO. So use cathode ray oscilloscope. That's answer. Use. It's called use. You must use it. You must use cathode ray oscilloscope. Okay, why they use cathode ray oscilloscope? Because they send the signal and the reflected signal very short time, maybe in few seconds. In few seconds, we cannot monitor by using stopwatch like this. We can wait for the sound wave to return back or ultrasound return back in few seconds. So in few seconds, very difficult to use stopwatch. So CRO is the best really. Best CRO. So best CRO, then in the CRO, they put a CRO like this. It's a CRO like this. They call it CRO. This one is a CRO. This one is CRO. In the CRO, we're using what we call it CRO, cathode ray oscilloscope. Cathode ray oscilloscope in the CRO. And cathode ray oscilloscope CRO, they get signal this. Good signal. This signal is a transmitted wave, ultrasound transmitted, and shorter wave. This one is shorter. So in between, this is called transmitted wave and the reflected wave. This is a transmitted wave, transmitted and a reflected wave. So this transmitted wave and the reflected wave within few seconds we can measure. We can within few seconds the interval time. Transmitted wave and the reflected wave, the interval time. Cellular mass we can measure by using CRO. Okay, so the transmitted wave and the reflected wave, they put the CRO in the CRO. They capture the CRO. So they capture CRO and they can measure the interval time, mass cellular mass. Okay, and the reason the transmitted and the reflected signal can display on CRO screen. That's the reason. The transmitted and the reflected signal can display it on the CRO screen. Okay. And question number C. The depth of the wreckage of the ship is 1000 meters into sea. A ship transmits a wave frequency of 50 kilohertz and receives an echo 2.4 seconds later. The speed of the wave in the water. The speed wave in the water. C1. The V equals to lambda F. Oh, so we cannot use V is equal to lambda F. We must use the depth. VTO2. This formula must use D, depth, the sea depth. The depth of wreckage is 1000 meter. And the V means beat. At the time they receive the echo means receive echo means the reflected wave. The reflected wave in 2.4. And you have the 2. So you cross multiply this one 2, then V equals to 833.33 meter per second. 833.33 meter per second. Okay, 833. Okay, and this is a formula. So D equals VT over 2. V means speed of sound wave or ultrasound. The T time, interval time, and the 2 must be there. You have 2. The what do you call it? The wavelength of the speed. So V equals to lambda f. So the V is 833.33. Lambda we don't know. The frequency, frequency 50 kilohertz. 50 kilohertz must change to hertz. 50 times 1000 must change to hertz, must change kilohertz, must change to hertz. So 50,000. So lambda equals to 0.017 meter. 0.017 meter. That's answer. Question D. Determine the most suitable ship that can detect underwater object accurately. So model X, because with CRO, ultrasound, and the frequency is 5 times 10 power 4 hertz. Okay, 50 kilohertz. So model X is used to call it used to detect the underwater object or ultrasound. Okay, question number section B. We do question section B. Essay question. We do section B questions. Okay. Question number 11. Question number 9. Question number 9. Question number 9. Question number 9. We do question number 9 first. Okay. Question number 9. Okay. Question number 9 first. We do one by one. Question number 9. Question number 9. Question section B. Question 9. Question 9. Diagram 9.1 shows two beaker A and B containing water and 0 degrees Celsius. Okay, question 9 I think is easy questions. Question 9 is easy. Question 10, I would like to reach this question 10 because question 10, there's one theory, one example which I didn't teach you. I waited for this question. Okay, based on the question. Okay, question 10, we do question 10 first. Because question 10 is a difficult question. Question 10 is a difficult question because I need to teach you the things. Okay, question 10. Because some extra point which I did not teach you in the normal class, I teach you in the questions. Okay. Question 9, question 10. 10.1 and 10.2 shows insulated copper wire is wrapped with around identical soft iron core from solenoid. The solenoid each connected to an emitter, the rheostat, and DC power supply. Okay, what is when the switch is on, the soft iron core became electromagnet, and the pin are attached to soft wire. This is one of the question, paper 3 question. This is paper 3 question. What is the difference between the two solenoid above two electromagnet? This electromagnet soft iron core wound with the copper wire. Okay, electromagnet means soft iron core wound with the copper wire. That is called electromagnet. I repeat again. Electromagnet, soft iron core wound with a copper wire and connected with current. So what is the difference? What is the manipulative variable here? What is the manipulative variable here? Manipulative variable here, this one is a coil. The coil. This one coil. This one, first thing. This one is battery. Okay, and this one, second one. Okay, it is both 10.1 and 10.2. So 10.1 and 10.2 is the same soft iron core, but the number of turns of the coil makes difference. Number of turns of the coil makes difference. This number of turns lesser, this number of turns more. This number of turns more. 10.2 is more turns. So another manipulative variable is, they never asked this question, but I will teach you this question. Paper 3 question, this famous paper 3 question. Another manipulative variable is current. Current. So for the current, they will use a rheostat. They use the rheostat. The rheostat, they fix number of turns. They put fixed number of turns. Number of turns we say, for example, number of turns like this. Okay. Number of turns same, but the current increases. How they increase current? By rheostat. Not number of batteries. Not number of batteries. It's not 2 battery or 3 battery. No. The battery will be same. Rheostat. Adjust the rheostat. Adjust the rheostat, higher current. Higher current is a lower current. Okay, adjust the rheostat. So because you must manipulate variable, current means not number of batteries. Number of batteries also can increase current, but number of batteries also increase. Number of battery increase also increase voltage. Voltage must be fixed. So in that case, two things are manipulated variable. Voltage will increase, current also increase. So instead of that, what they do, the voltage fix it. Voltage fix it by number of batteries. Say, let's say 2 battery. So voltage 3 volt, 3 volt. The voltage say fixed, but adjust the rheostat. Adjust the rheostat. Adjust the rheostat. Increase the current, decrease the current. Okay. So two factors here. One is number of turns. Another is current, magnitude of current. So that determines the strength of electromagnet. Okay, and the number of pins. Maybe the pins more attached more. These are pins. Pins. Here more pins. More pins attached. Attach more pins. Okay, what is the meaning of electromagnet? Okay. Conductor which can produce magnetic field. Conductor which can produce a magnetic field. That's called electromagnet. Using 10.1 and 10.2, compare the number of turns of the coil and the number of pins attached to the electromagnet, the reading of the meter. Relate the number of turns of coil, number of paper attached to the non-terminal relation, regard relationship between the number of turns and the coil and the strength of the electromagnet. So first of all, okay. The first point, number of turns of the coil in diagram 10.2 is more than 10.1. Number of turns. So first they are asked compare the number of turns. So number of turns of the coil. Number of turns of the coil in diagram 10.2 is more than 10.1. More. Second point, the more pin attached, okay? Okay. Number of pin attracted to soft iron core. Number of pin attracted to soft iron core in diagram 10.2 is more than 10.1. 10.2 is more than 10.1. So number of turns also more in 10.1. Number of pin attracted or attached. Number of pin attracted or attached is also in 10.2 is more than 10.1. Okay, these are 2 points lah. And the reading emitter. The reading on the emitter. The reading emitter 10.1 and 10.2 is same lah. Or another thing, another reading emitter reading same. Same current. In other words, current must be same. Current must be constant variable lah. Current must be constant variable. So the manipulative variable. What is the manipulative MV? This question MV. MV. What's MV? Number of turns. Number of turns. What's RV? What's RV? RV. Responding variable. Strength of magnet. Strength of electromagnet. Strength of electromagnet. What is CV? What is CV? What is CV? CV means constant variable. What's the constant variable in this question? What is constant variable? Constant variable current. Current. Emitter reading same. The current is same. So MV number of turns are called. Number of turns. RV is strength of electromagnet. How do you measure strength of electromagnet? Number of turns you can measure directly. You can put 20 turns, 10 turns, or 20 turns, 30 turns, or 5 turns. So number of turns you can measure. Number of turns you measure. You can count it. But how do you measure strength of electromagnet? How do you measure strength of electromagnet? CV current also can measure by using emitter. But how do we measure strength of electromagnet? Strength of electromagnet. The strength of electromagnet is measured by using number of pin attached. Number of pin attached or number of pin attracted. That will cause the strength of electromagnet to measure, to strength of electromagnet to measure. To measure number of pin. So when you write this question come out in MV, RV, CV, paper section B, paper 3 section B question. Paper 3 section B question. Let's say same question come out. MV number of turns, RV strength of electromagnet. In the bracket you want to put number of pins. Number of pins attached. Or instead of strength of electromagnet, number of pins also you can see. But better you put strength of electromagnet or number of pins. Number of pins attracted or attached. CV current. Okay, the same, that's not the question I gave you, the emitter, the rheostat, adjust the rheostat, number of turns fix it. So other question, the MV, the another question, MV is current. Another question, another type question, the MV is current. RV, strength of electromagnet, same strength of electromagnet or number of pin attached. CV means number of turns. Number of turns of the coil. Number of turns of the coil. So this is another 2 questions. This question also can come out, this question come out. Paper 3 question. This is a paper 3 question. Paper 2 question can come to paper 3 questions. Okay. Paper 3 question, number of MV is number of turns. RV is strength of electromagnet or number of pin attached. CV is current. So one question, CV. Another question, MV can be current. Current manipulate, how they manipulate current? By using rheostat. By using rheostat, not by using battery. Not using 2 battery, 3 battery, no. They're using 1 battery or 2 battery, no. Battery is not a factor. By using rheostat. Okay. The RV strength of electromagnet or number of pin attached. And the CV is number of turns. So this is another type of question. Paper 3 questions. Okay. Okay, the 3 questions we answered. Okay, and current, okay. And they asked relate the number of turns of the coil with the number of paper clips attached to the electromagnet. To make deduction regarding the relationship between the number of turns of the coil and the strength of the electromagnet. Okay. So then we call it the question answer point 4. When the number of turns increases, number of pin attracted also increases. When the number of turns increases, number of pin attracted also increases. Okay, the fifth point deduction regarding the relation between number of turns, coil, strength, and magnet. So, when the number of number of turns of the coil and strength of the turn. When the number of turns, okay, fifth point, when the number of turns of the coil or number of turns of the coil or solenoid increases, when the number of turns of the coil or the solenoid increases, the strength of electromagnet also increases. The strength of electromagnet also increases. Another word, current also. Another question. When the current increases, the strength of electromagnet increases. Strength of electromagnet. This question is a number of turns. So the fifth point, when the number of turns of the coil of solenoid increases, the strength of electromagnet also increases. Okay, question number C. Question number C is the one question I want to teach you now. Okay. Question C is the one I teach you. Okay. Question C. Okay. Diagram 13 points shows two aluminum rods connected to two different circuits and hung to each other. State what happened to aluminum rods when both switches are closed. Explain the answer. This is a question I want to teach you. Okay. This is a wire and the aluminum rod like this. And this is wire. And okay, positive battery, negative battery here. Okay, and another rod. Okay, these are two rods. Okay, I draw the current flow. First. This is a current flow. This current flow like this. Okay, this current flow like this. Okay, current flow like this. Current flow like this. This also current flow like this. This here, current flow like this. Okay, so this current flow, these are two aluminum rods. These two aluminum rods. Okay, current flow like this. Okay, what happened? When the current flow, you must draw the the magnetic field. Okay, the electromagnetic field. So this two wires. Okay, this current. These two wires current flowing like this. So the current flow like this. The current flow shows current flow into wire in whiteboard lah. Current flow into whiteboard lah. So you flow the current. So you must use the right hand green tool. Anti-clockwise, clockwise. This one clockwise. This is clockwise. So this one is clockwise. It's clockwise. Okay. And another thing, another wire also current going like this. These two wires current going like this. Current go like this. Current go like this. Two wire. So this also clockwise. This also clockwise. So this one clockwise. This also clockwise. Okay, clockwise. Clockwise means okay, this is clockwise. This is clockwise. This is clockwise. Okay. This one. Okay. This is clockwise. This is clockwise. This is clockwise. They are clockwise. 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 So and yeah. It's not clockwise. Oh, clockwise. Okay. This one is this. Okay. Okay. Now this one clockwise. This also clockwise. This is clockwise. This is clockwise. But if you see the center portion, this one is very difficult to understand. Difficult to understand. Okay, try to understand this one because I will draw this picture. I will draw and teach you. Okay. This one clockwise. This also clockwise. But if this clockwise, this one clockwise, this clockwise, this clockwise, and this clockwise. So if this clockwise, this also clockwise, but they anti each other. This one coming down, they are going upwards, but clockwise. Both also clockwise, but in the center portion, one is coming down, one is going up. Coming down, going up is cancel each other. So the magnetic field is weak in the middle because the magnetic field coming here and going up. Here coming down and going up. Coming down, going up. So this one, the magnetic field cancel each other. Weak. Here magnetic field is stronger. Both magnetic field because this one clockwise, here clockwise. So it's further. So this magnetic field here stronger. Strong. Here strong. So strong and strong. Where will do? Strong and strong will push towards the weak portion. So the strong and strong outside strong because it never never cancel each other. So the magnetic field never meet. This magnetic field is outside here, this magnetic field outside here. So it's never meet. But the center portion, the magnetic field meet. The center portion, magnetic field meet each other. So it's cancel each other. So the magnetic field is stronger and stronger. So stronger push towards the weak portion. So that means the magnetic field. This one magnetic field push and the magnetic push is causing these two rods push each other or pull towards each other. The magnetic field pull towards each other. Okay, pull towards each other. Okay. When the current is flowing same direction, rod, same direction, the causing the two aluminum rod push each other or pull each other. So because strong magnetic field, the strong magnetic field push towards the weak magnetic field. Weak magnetic field center because cancel each other. Okay. If the current other way down, one current up, one current down. This current is same direction. The aluminum rod current same direction. They pull each other. Two aluminum rod. If the current opposite direction, one is going towards, one is going up, one is coming down. So the aluminum rod push each other. This one aluminum rod push. two aluminum rod pull together, pull each other. Because current is same direction. Current is same direction. I explained to you already. Because weak magnetic field is center and strong magnetic field is outside. But if the two rods, current like this, okay, one current going up, one current down. So this one is this. They pull, they push each other. They are what do you call it? They push, repel. So attract each other. This one repel each other. Because same thing. You can draw the current flow and you can draw the magnetic field. The magnetic field is weaker, outside weaker, and both sides outside weaker, and the center portion is stronger. Center portion, you can draw this one current and direction of magnetic field. You will draw and see. Center portion is stronger, the outside portion weaker. So because of that, they repel each other. The strong from strong to good weak. Strong good weak. The strong is center portion. Strong center portion. The magnetic field strong and this weak magnetic field. This weak magnetic field. So strong from strong you go to weak. So this one repel. But this one strong outside strong. Center portion weak. So it's pull each other or attract each other. Can you understand? Attract each other. This one is a repel. When current going like this, current direction different. You can draw the magnetic field direction. You can see that this line. Okay, because you're weak, you're strong. Center portion is strong. You can hear strong outside, the weak is center. So pull or attract each other. Okay. I'll explain to you already. If you cannot understand, then we will see later. Okay, the answer for this question, see, two aluminum rods attract each other. The answer for this question, two aluminum rods attract each other. They explain. Okay, second point, current flowing through aluminum rod in the same direction. Current flowing through the aluminum rod in the same direction, going up. Same direction, that's your same direction. Okay, current flowing through the aluminum rods in the same direction. Third point, magnetic field produced by the current in the rods combine to form resultant magnetic field. Magnetic field produced by the current in the rods combine to form a resultant magnetic field. This one current magnetic field, resultant magnetic field. One is going both also clockwise, magnetic field clockwise. This one clockwise, go down and go up. Go out and go down. So one go down, one go up, magnetic field. Okay. A weak magnetic field, resultant magnetic field, a magnetic field produced by the current in the rods combine to form a resultant magnetic field. Resultant means combine magnetic field, because two magnetic field combine, two rods combine magnetic field. A weak magnetic field is produced in the region between rods. A weak magnetic field produced in the region between rods. Between rods means center portion rods. Because field lines are opposite direction. Field lines, one is coming down, one is going up. Because field lines are opposite direction, thus force are acting. Force are acting inwards to pull thus the force acting inward direction. The forces are acting inward direction to pull the two aluminum rod each other, or to pull or to attract the aluminum rod each other. To pull or to attract the aluminum rod each other. The aluminum rod come together. This one is aluminum rod. Go out, or repel. This one attract. This one repel. Okay. That's answer. Okay. Okay. Question number D. Question number D. Diagram 10 shows sequential transfer which is not efficient. Use appropriate physics concept. Explain how you modify transformer in Legan 10.4. Increase efficiency. So it's very famous question. Very famous question. Efficiency of transformer. Increase efficiency of transformer. Very famous question. Efficiency transformer. Because this question you must do in table formula. Okay. This concept of modification. And second one, reasons. Okay, modification is it okay? 2, 3, 4, 5 characteristics because 10 marks. 1, 2, 3, 4, 5. The first type of the coil wire. Use copper wire. Use copper wire. Use copper wire. The reason it has a low resistance of good conductor. It's a good conductor. Second question, the thickness of the coil wire. Use a thicker wire. Use a thicker wire, thicker copper wire to reduce resistance. First thing, use copper wire, copper coil wire, because copper wire is a good conductor. Good conductor, naturally low resistance. Use thicker wire. The coil wire must thick coil wire. The coil must thick coil wire. Use thicker coil wire, reduce resistance. And third thing, type of the core. Type of the core. Use a soft iron core. Soft iron core. So the soft iron core can magnetize soft iron core can demagnetize easily. And the fifth one, the characteristic of core. You must be laminated iron core. Laminated iron core. Characteristic of core. The fourth point. Characteristic of core, laminated iron core. To reduce eddy current. Okay. And the arrangement of the primary coil and secondary coil. Arrangement. So the wine on top, Gillican. Wine secondary coil. On top of the primary coil. So I had teach you this one before. I taught this one before. So this one is the coil it is. This one is secondary coil. This is primary coil. This is secondary coil. So primary coil, secondary coil is one together. One secondary coil on top of primary coil to reduce leakage of magnetic field. To reduce leakage of magnetic field. Okay, that's it. The 5 characteristic. Okay, so I finished questions. I finished lesson today with this. Then maybe next class we meet again. Okay, we do the rest of the question essay. It's a good question essay questions. Okay, thank you very much.